Description of the trends of the periodic table by James McIntyre and Grayson Marlowe.
Atomic radius. The atomic radius is the length of the outside of the atom to the outside of the nucleus. The outside of the atom is the same as the outermost shell, so the number of shells increases the atomic radius. The period shows the number of energy levels for each element. Since the period number increases as you go down the group, the atomic radii increase as well. The atomic radii decreases right across the period because the atomic number increases the further right that the element is on the period. The more protons there are, the greater the gravitational pull of the nucleus. This decreases the size of the atom by shrinking it through its gravitational pull. Atomic radius length on the periodic table. As you go down the group, the atomic radius length increases. However, as you go right across the period, it decreases. Ionization energy. Ionization energy is the amount of energy it takes an atom to steal an electron from another atom. This is called ionization energy because when the atom captures or gives up an electron, it is called an ion. The ionization energy is greater to the right side of the periodic table because the elements are closer to satisfying their goal of filling up their last energy level. For example, if you were saving up for a bike that costs $45 and you had $40, you would want to save up your money until you got a bike. Similarly, the elements close to a full shell want to hold on to their electrons. The ionization energy is also greater the further up the group the element is. This is because they have fewer electrons to give up, so they have a greater gravitational pull on each electron, which requires more energy to be stolen. Ionization energy on the periodic table. As you go down the group, the ionization energy decreases. However, as you go right across the period, it increases.
Electronegativity. Electronegativity is how well the atom attracts other electrons to gain. The electronegativity increases right across the period because the further to the right an element is, the closer it is to having a full outer shell. For instance, chlorine has a high electronegativity because it needs one more electron to have a full shell. The electronegativity decreases as you go down the group. This is because as you go down the group, the outer energy level is further and further from the nucleus. This means that the nucleus has a less powerful gravitational pull on new electrons. The element at the top of the group would have the highest gravitational pull to attract new electrons, thus having the highest electronegativity. Electronegativity on the periodic table. As you go down a group, the electronegativity decreases. However, as you go across a period, the electronegativity increases. Noble gases are excluded from electronegativity because they are non-reactive.